See how far it'll let us go. So naive, as I said, for any lymphocyte, whether it be a B cell or a T cell, this means they haven't encountered antigen yet. That's all that means, right? They're naive to the bad guys. Whenever a B cell or T cell becomes activated, it's going to proliferate because, again, we need more than just one of them. We need a whole bunch of them to do their job. And to do their job, they have to be able to be effective, right? So some of them have to differentiate into these effector cells that actually do something. So for a B cell, that would be into a plasma cell that secretes antibodies, right? For a T cell, that would just be an activated T cell that goes and helps B cells and macrophages. For a cytotoxic T cell, that's a cell that now is hunting down the bad guys, right? Cells that are infected, and they're going to kill them. But the first step is activation and proliferation, right? And then you're going to differentiate into these effector cells. And then some of them aren't going to do that. They're going to become memory cells, right? But again, they're descendants of activated only lymphocytes. You have to have seen and recognized a specific antigen. And again, these are the ones that save our butt when we see something again. These are the ones that allow us to be immune, because those other effector cells, the plasma cells and the helper T cells that went out and did their job, and the cytotoxic CD8 T cells, once their job is done, they're going to die off, right? They're going to go by apoptosis. So T cells, helper T cells specifically, are sometimes needed for B cell activation, right? And that's when an antigen is referred to as T dependent, right? When you need a T cell in order for the response to happen. There are some antigens out there that the B cell does not need the T cell help. In that case, it's a T independent antigen. And it's really dependent on the antigen on whether the B cell is going to need help or not. And then, of course, what's the similarities and differences? What happens for primary response versus when we see something a second time or thereafter? So remember that step up here, right, for a B cell, sometimes he needs the helper T cells to come over and confirm. So a B cell, when it interacts with an antigen, is going to internalize it, and then it's going to present it on MHC class 2, right? That's the clef that it has. And the reason why it has MHC class 2 is this is going to allow it to talk to the helper T cells, which are CD4. So I always tell myself a little story with that. CD4, I think of 4-H, right? That organization teaches kids about animals and all that. But 4 for CD4, H for what? Helper, because that's what CD4 T cells are. They're helper T cells, right? And then I just sing to myself, 2, 4, 6, 8, who do we appreciate? Because helper CD4 T cells interact with MHC class 2. So, right, 2, 4, 6, 8, you get it? These are the stories we tell ourselves so we can remember these numbers, right, and their associations. So that's what's worked for me. Maybe it will help you, right? So, you know that saying everyone says, 2, 4, 6, 8, who do we appreciate? So you know 2 and 4, right? MHC class 2 and CD4 go together. And I appreciate 4-H. That's who I appreciate. You see? All right, I know. I'm corny and horrible sometimes, but hey, whatever works, right? It has worked for 20 plus years for me. So there's two possibilities, right? The helper T cell is going to recognize that same antigen, and it's going to help activate this B cell. Or it's not, and the B cell's not going to get activated. And again, it's not just a secret handshake, right? They're going to communicate with each other via cytokines about what's going on here. So that's T dependent, right? The T cell is needed to help the B cell become activated and proliferate. So this is looking at antibody response. It says here 10 to 12 days. The pretty regularly accepted average is about 7 to 14 days, though. And this is the time from when you're first exposed to the antigen, the very, very first time you ever see this specific antigen, and the time it takes for antibodies to be produced could vary between 7 and 14 days. So just like I talked about with the flu vaccine, right? You go get the shot. How long is it going to take before your body produces antibodies? On average, 7 to 14 days. So are you protected in that lag period before you're making antibodies? No. Right? But once you start making antibodies, and the first antibody you're going to make is IgM, and then you may, depending on the antigen, switch to IgG. That's your most common antibody, your most prevalent, your most long-lived. And also the one that can do what, as far as women are concerned? It can cross the placenta. You also secrete it in the first milk you produce, called the colostrum, to help protect your baby. The rest of the time, what do you produce in your breast milk? IG. It's the one that's most abundant. It goes in your mucus, goes in your breast milk, your tears. It's a dimer in that when it's secreted. Two Y's hooked together. IgA. IgA. And then if you experience allergy like me, it'll be IgE. And I always tell my students, just remember E for Erica and her horrible allergies. And you won't ever forget that IgE. Although mine are better, now that I don't eat wheat. Me and that inflammatory person. Crap, was killing me. So look here, right? So that's first response, and then the numbers are going to die off as the number of antibodies, right, are going to die off as we eliminate the invader. And then, oh crap, right, you get exposed to this very same antigen again. Do you have any lag period? No, it's like almost instantaneous. Antibodies start being produced, and look at how quickly the switch is, and even how much more is produced very quickly. They're like, oh crap, he's back again. We're not messing with him this time. Full force, right? Major attack. Not dealing with this again. So the great thing about secondary as opposed to primary is no lag period, right? Because you've already seen this guy. You already knows what he looks like. And who's being activated here? Not naive cells. Your second exposure, who's being activated? Dylan said it. Memory cells. Memory cells. So it's faster, it's more aggressive because you already know what you're dealing with. Where this first time around, right, they're trying to figure it out. And that, unfortunately, takes time. The bad news is if your innate immune response can't keep this under control, before adaptive, which is more specific and more aggressive, comes online, you could potentially die. So we take advantage of this memory component, right? And that sometimes this first exposure is in the form of a vaccine, which is a weakened form, usually, of a really bad pathogen, or an inactivated form of a toxin, in the case of tetanus and diphtheria. We're not vaccinating you against the infection, we're actually vaccinating you against the toxin that the infection could cause. We're not going to stop the infection, we're going to stop those toxins from really killing you, because we're going to get your body to make antibodies against them before it ever sees it. Because you don't have time when it comes to those toxins, right, to wait around for your body to figure it out. Make sense? And this is how we can be immune, right? When we've seen something before, we know what it is, we shouldn't get sick from it again. So here's those plasma cells, as I said. Look at that huge, rough endoplasmic reticulum. But this takes time. Did I complain to you guys about Scorpion already? A TV show? Bunch of geniuses. I was watching it for a while, but then they upset me. And my husband doesn't like it, so I had to watch it on my own time instead of our TV time. But guy gets bit by a snake, right? So he's got venom in him. They go break into some place where they have the snakes. The guy wrestles the snake, gets the snake venom. They come back and they inject it into like a guinea pig. And then like an hour or two later, they're sucking the blood and spitting the blood down out of the guinea pig to give the antibodies to the guy bit by the snake. Is that possible? Yes. What is wrong with that? They did it in a half-an-hour episode. Is that guinea pig going to produce those antibodies in the matter of minutes? No, it's going to be 7 to 14 days, right? So it can be done, right? The time frame is just way off, right? And it wouldn't probably save the guy that was bitten by the snake. That venom is pretty, depending on the type of venom, right? Because there's different types of venom, right? Ones that will coagulate your blood, others that will affect your nerves. Some snakes have both of those types of venoms. This is why I run from all snakes in Louisiana. So we have like all the major venomous snakes here. But this is also why they want to know what got you, right? So they can maybe be specific as to the anti-venom they're going to give you. But they should have just broke into the anti-venom cabinet at that snake place that they went to, because I can guarantee you that any place that deals with venomous snakes, they keep anti-venom on hand. Right.
So is there a way to get the blood from that
Guinea pig?
tribe in Africa that's
Immune to HIV? No, because their blood's not going to help you. Why they're immune is because their T cells, their receptor, that CD4 marker that their cells use to communicate with their cells, that's the same thing that the virus attaches to. Theirs is so different that the virus doesn't attach. That's how they're immune. So it's a different type of immunity in that case. No. You would literally have to genetically alter everybody. Like, we'd have to become GMOs, genetically modified organisms, to be immune to HIV in the way that they are immune. Not going to happen. Be nice, though. But that's where, understanding how the system works, right? You can understand that that's not possible. So titer is just the concentration, right? How many antibodies do you have? When the B cells proliferate, when they go through this clonal expansion, they don't make exact copies of themselves. They actually purposely mutate their DNA that tells them how to make their antibody. They're basically B cell receptor. And the hope is that their antibody will actually become even better that'll bind to the antigen even better than before, have a greater affinity. Now, of course, this is random, so sometimes, unfortunately, they'll become less binding, right? Have less affinity for the antigen. And they won't get a signal to continue on, right? Because they don't bind that well. But if they become even better, then they're going to be selected for. So notice these guys are 3 pluses, right? The best binding with the antigen. Where this guy is only a 2 plus by standard, and it doesn't get a signal to continue. So although they're clones, which would mean that they are identical, they aren't truly identical. They go through this process of affinity maturation, trying to get better and better, stronger binding to the antigen, right? Because the best fit is going to be the most helpful. The other thing they're going to do is switch between the 5 different classes that we've been mentioning. The first class that you produce is IgM. That's the first programmed segment in the DNA. And then depending on where the B cell is and what type of response we need, it'll get a signal, usually from the T cells, right? That's who's going to help him switch, right? If you have a T-independent antigen, you're just making IgM. That's it. To switch to IgG or IgE or IgA, the T cell is involved in that switch, right? It's going to tell the B cell you need to make a switch. So if it's mucus-associated lymphoid tissue, where these T cells are, and this is happening, which switch would we make to what class of antibody for in the mucus-associated lymphoid tissue? Yeah, we want to switch to IgA. It's on the slide. So in the lymph nodes, IgG, right? Because that's going to go all throughout the body. And then if you're an allergic individual like me, it's probably going to be E, in my nose. Oh, Lord, help me. I can't breathe through my nose today. I ran out of Flonase. And we walked to morning call, and they were mowing the grass. One of the high school girls, our TA, she's so sweet. She was like going like this to try. I said, honey, that ain't gonna work. She's like trying to push the air away from me. But like the guy who was mowing the grass must have thought, like, I don't know what he thought, but he like slowed down and moved away from us, which was nice. It still wasn't gonna matter. Do you know that ragweed pollen can travel 400 miles to oil rigs out in the Gulf? People who work on oil rigs out in the Gulf and have allergies still experience allergies all the way out there. 400 miles away from land. That stuff travels. You can't get away from it, really. So unfortunately for me, we just keep turning this system on. Especially when you're out of allergy medicine. It was in with the stuff I bought to make the ice cream this morning. And they're like, what's this? I said, my allergy medicine. Give that to me. I need it. Except stupid me should have took it before we went outside. Now I can't breathe through my nose. Alright, so this next part, we are going to take our break because I'm going to try and do some drawing to help us with this. So let's take our 15-minute break. So antibodies, my absolute favorite proteins, because they're so awesome. So you guys already kind of touched on it because you did your homework, right? The different classes of antibodies, and this is determined by their heavy chain. And of course, all this is encoded in your DNA. So this is representing DNA. And there are 2 pieces and 2 copies of each piece that make up a single monomer of an antibody. So it's going to go through this. So it'll be a little bit of review of the different components of an antibody. And this is talking through, down to the DNA level, how it is that each B cell is different. Because this is what they do to their DNA to make their own different, unique antibody. So I'm going to go ahead and play this one.
Human cells do not have enough DNA to have separate genes for each antibody molecule.